Good morning, my friends. Today we're talking about function notation, which is 12b. We're going to evaluate functions expressed in function notation given one or more elements to their domains. So a function is a relation in which each domain or x value corresponds with exactly one y value, which is the range. The function notation is a mathematical notation that describes a specific function. That is your function notation, or how you write the information down. So functions are named with a letter. F, G, or C are going to be your most common function letters, and they indicate the independent variable, which is your domain, inside of the parentheses. So when you see it on Desmos, or whenever you're trying to evaluate the information, you're going to put y first, is equal to f, which is just the name of the function, of x. The way that you say this is f, which is the name. I'm going to highlight that in blue. Of x, which I'm going to highlight in y. Again, you say f of x. So let's look at some of these examples and the way that they wrote them. It says on the left, function notation, f of x. Your function is f. Your domain value is x, and the output is f of x. On the next example, it's h of t. The function is h. The input is t. And then you would say h of t. In the following example, it is the notation c of n. So the function is c. The input is n. And the output is c of n. So on our first example, it says the equation y equals 2x plus 4 represents a function. Rewrite y equals 2x plus 4 using function notation, but name the function using the first letter of your name. So what I'm going to do is I'm going to use my name, because my name is Miss J or Miss Jackson. I'm going to put the letter J first. J of x is equal to 2x plus 4. All I did was name it for my name, J of x equals 2x plus 4. You use your name or the letter of your name. Now, I will tell you, if your name starts with an X, you would put X first, of x, but that's very, very confusing. Saying x of x doesn't make a whole lot of sense when we're talking about math. So you would need to put a different letter for the input and the output, because this is confusing. Once you have all that down, turn your paper over and let's look at some of the examples. Now we're going to evaluate the functions using function notation. Since function notation relates the input and output of the function rule, it can be used to indicate how to evaluate the information. When I say evaluate, all I want you to remember is that we are plugging in one set of information into another point. So I'm going to highlight these things to make it a little bit easier for you so that you know exactly what it is that we're going to evaluate. In our first example, it says if g of x equals 5x minus 2, what is the value of g of 6? So what we're looking for is g of 6 means that we're going to plug it in every time we see an x. So on the next line, it says g of 6 equals 5 times 6 minus 2. They substituted in the 6 for our x, and then they evaluated the information to get the answer. In your Desmos, I want everybody to pull it up, Desmos test mode. What you would put in is y equals 5 open parentheses 6 equals 2. 5 open parentheses 6 minus 2. That will give you the evaluation of g of 6, and your answer will be 28. That is your simplified answer, and that is what you want in the very end. All right, everybody, let's try example number 1 together. It says, given p of n equals 1/2 times n minus 5 to the second power, what is the value of p of n? Now I'm going to go in here and I'm going to also highlight my n because that is what I'm replacing. And then I'm going to rewrite my equation. Everybody write with me. P of 9, because I'm replacing that n with a 9, equals 1/2 times 9 minus 5 raised to the second power. Now we are raising things to the second power now, so if you don't know how to do that, go to the Desmos test mode, go to the very bottom where it has the keyboard, and you can find the raise to the second power that way. If you like to do it on your keyboard, it's Shift 6 and then press 2. All right, so let's go ahead and evaluate this information. In Desmos, you don't put p of 9, you're just going to put y equals, but I'm going to write it as it should be, p of 9. I'm going to type in 1/2 times 9 minus 5 raised to the second power, and that is going to evaluate out to being equal to 8. Does your paper look like my paper? If it does, fantastic. That is as easy as it gets. All you're doing is plugging in the information that it provided into the letter that it tells you to put it there, and that is it. All right, let's try it again on example number 2. It says, given f of x is equal to 2 times 12 minus x, what is the value of f of negative 2? Again, I'm going to highlight my f of negative 2. I know that that means that I am replacing my x value here and here, and that is how I'm going to write it in my Desmos. So let's rewrite our equation first so that we can all be on the same page and we know exactly what we're going to put into Desmos. We have f of negative 2 is equal to 2 times 12 minus negative 2, close parentheses. Now I want you guys to notice that I put this negative and negative together. If you are using Desmos, it understands that a negative times a negative, this right here, makes a positive. If this irks your nerves so bad, you can fix this for yourself and put 12 plus 2. Don't change anything else, but you can change that one part if it irks your nerves super bad. If it doesn't, leave it alone. Desmos will fix it for you. Once you have evaluated this function, again, super fast, once you put in 2 times 12 minus negative 2 into your Desmos, you should get 28 as your answer. 28 is your final answer. This is how you should write it on your paper, because you are evaluating f of negative 2. All right, my friends, let's go to example number 3. It says, given h of t equals negative 4.9t squared plus 10t plus 150, find h of 10. Now again, we are going to substitute 10 in every single time we see t. So we're going to have to do it more than once this time. But no worries, let's write all our things down first, and then we can go into substitution. We have h of 10 equals negative 4.9 times 10 squared plus 10t plus 150. All right. Make sure your paper looks like my paper. Let's put it into Desmos and let's see what we get. I'm going to pause right here so that you can do that. Once you have the answer, please come back and check to see if you got what I got. Welcome back, my friends. I hope that you wrote all of this correctly and you got negative 240. If you didn't, please make sure you're putting your parentheses where they go and that you raised it to the second power instead of timesing it by 2. Those are two very different things. One means I'm multiplying it by itself, and one means I'm timesing it by 2. So make sure that you're putting in your squared sign instead of times 2. If you didn't get it right, try it again. If you did, fantastic. Let's move on. We have example number 4. It says given C of n is equal to 2/5 n plus 7n. What is the value of C of 5? Again, we are going to write it like we see it, except we're going to substitute in our 5 for our n's. So when we evaluate C of 5, we have it's equal to 2 over 5 times 5 plus 7 times 5. Close those parentheses up. Make sure you're putting this into Desmos properly. Once you do that, your answer should be the same as mine. If not, please go back and make sure you're doing this for yourself. If you have any questions, please ask so that we can get you back on the right track. All right, my friends, we only have 2 examples left, and these are word problems. Please do not fret. These are not as difficult as they seem. Sometimes there's a lot of words that are kind of unnecessary, but the information in there with the numbers is what you need. So let's look at this. It says the manager of a grocery store determined that the number of bananas remaining on the shelves at her store can be determined by the function b of n equals 150 minus 6n, where n is the number of hours since the store opened. So the very important information in this is b of n equals, b of n equals 150 minus 6n. Now what we want to know is how many bananas are left on the shelves after the store has been open for 6 hours. 6 hours. So that means that's what we're going to substitute in to the function that we're going to create. So the function name is b. The function name is b. Remember, we do that at the very beginning of our evaluation. B of n is equal to 150 minus 6n. Now we know that we're going to substitute n for the number 6 because 6 is how many hours that the store is open. So let's rewrite again. B of 6 is equal to 150 minus 6 times 6. Because again, that's how many hours the store is open. And we want to know how many bananas that they sell in that time. So in your Desmos, I want you to put 150 minus 6 times 6. That will give you exactly how many bananas you sell when the store is open for 6 hours. I'm going to pause so that you can do that for yourself. You should have received 114 bananas in sales. Now, the reason that I put bananas behind it is because I'm looking for a value. And in this, it is important, so you write the word bananas after the 114. All right? Not so bad. Let's try one last one before you do your independent practice. I have a train conductor determine the distance in miles a high-speed train was from its destination using D of H equals 1,375 minus 110H. I'm going to go ahead and highlight that whole equation. It's important. Where H is the number of hours traveled. How far is the train from its destination after 8 hours? So let's write down the equation that it provided. It said D of H is equal to 1,375 minus 110H. Now I know that the train traveled for 8 hours. So I'm going to plug that into my equation so that I can evaluate that information to see exactly how far the train traveled. I want you guys to go to your Desmos, and I'm going to pause so that you can tell me what you got. Write it onto your paper. You know that it will be in miles. And I'll wait for you to write my answer down too. All right, my friends, I hope that you got 495 miles. If you didn't, go back and try it again and see if you made a mistake somewhere. Hopefully you didn't. But if you did, that is okay. We're all learning. I hope this lesson was pretty easy for you. Now it's time for your independent practice.